So, hello everyone at our March meetup of the software engineering community of MMS. Um, First, let me welcome you by introducing ourselves. We are the software engineering community. We now exist for 10 years. 10 years, yes. And we were created, or we spawned in T-Systems MMS, and well, our goals are exchange of knowledge, creating networks for local and remote professionals, and furthering the understanding of software development and software architecture and everything that is, well, adjacent to this discipline. And we have a lot of meetups and channels you can use to contact us. Especially in about a month in time, we're gonna have our next Dev Day in the Börse Dresden, on the Messe Dresden, where we can meet in person and enjoy really nice talks and presentations, including a presentation of Constanze Kurz from CCC this year as a keynote. It should be a really great event, and I advise anyone to join there and have a joyful day and a knowledgeable day with all of us. But today we're here because of Kevlin, and Kevlin is going to talk to us about the architecture as knowledge. We had Kevlin again. We had Kevlin, I think, half a year ago already, and he was talking about the architecture of uncertainty. Now he's more certain and has more knowledge for us to absorb into our architectural knowledge. And well, with this, Kevlin, the stage is yours.
Thank you very much, Martin. Okay, let me just get all the screen sharing sorted. Okay, let's do that and share. Okay. Let me now move my screen, adjust the sizing of everything because everything's just changed in a way I did not expect it to. So let's just resize this. Okay, right. I just checked my I just checked oh, there's a thing I need to change. Okay. That don't think I want that. Just try something else. Yeah, so I just checked actually. The interesting thing is that so let me keep a chat window open. If you have any questions as we are going, feel free to pop them in the chat. I will try to give some space at the end for Q&A, but I will say in advance I'm not very good at that. But feel free to ask questions, put them in the chat as we go. So that's quite a nice feature, of course, of being able to do this stuff online, is that it's okay to chat while somebody else is speaking. I just checked the dates, and it turns out it was not half a year ago. It was actually almost exactly a year ago, 11 months ago. Yes, time flies. Our sense of perception, time perception, is very poor, which somehow plays into what I'm going to talk about this evening. So yes, good evening. And as Martin said, I'm going to follow on from the architecture of uncertainty. There's a little bit of overlap. And what I'm going to try and do is actually, in one sense, structure the uncertainty that I talked about. I'm going to provide you with a framework here to think about this. And I'm going to pick some examples of what I mean by knowledge and knowability. That's an important thing. And the fact that our knowledge changes with time. And offer you a way of reasoning about that and thinking about that. So my name is Kevlin Henney. This is what I look like when I'm standing up. And let me just... Yeah, that's fine. So that's all my social details. Feel free to connect with me, follow up via any of these. And so the first thing, by way also of introduction, let me think, myself and Trisha G edited this book kind of at the beginning of the first wave of lockdowns. We finished editing it in 2020. 97 Things Every Java Programmer Should Know. it kind of follows on the heels of, slowly on the heels of a book I edited 10 years before, 97 Things Every Programmer Should Know. Prior to that, I co-authored a couple of volumes in the pattern-oriented software architecture series with Frank Bushman and Doug Schmidt. And these are probably the most relevant in terms of what I want to talk about this evening. We will, because obviously they've got the word software architecture in the title, and I have the architecture word in my title, but also patterns. I'm not going to talk about patterns in general. I'm going to talk about a much more specific element of them. So let me take you back even further than these books, to Grace Hopper. Basically one of the people responsible in the 50s for advancing the state of compiler technology, helping create the language COBOL, and so on. And a formidable woman with a lot of great insights. And she made this wonderful observation. To me, programming is more than an important practical art, which it certainly is, but it goes further. It is also a gigantic undertaking in the foundations of knowledge. For me, this is one of the most important ideas, the idea that we often use this phrase, knowledge worker. And that term used to feel fairly empty to me, fairly hollow. It didn't have a lot of resonance or meaning. And then one year I suddenly thought, you know what? I think I now understand the deep truth inside that statement. I think you might want to put yourself on mute. Yeah. Tony, you're on. Yeah, there we go. Great.
Okay. 3/4 von den, ja gut, von den Überstunden, also nicht von dem Betrag jetzt. Weil das war ja gerade der 80 oder der Komplettbetrag quasi.
So we've got a couple of people who are not
okay,
on
alles klar,
mute.
gut.
Let's have a look at that.
Ja.
Can I change that? I think only the host can modify that.
Okay, das heißt.
No, I can't either.
Okay.
Now it's muted.
So there is an idea here that when we are talking about software development, what we're doing is we are taking knowledge, and the knowledge comes from the domain. We are discovering the domain. Knowledge comes with our knowledge of technology. It also comes in the way that we work with one another. And the resulting software system is quite literally a codification of that knowledge. So that's what we mean when we say that this is a knowledge-based discipline. That's what we mean when we say we're knowledge workers. So knowledge is the most fundamental idea, the most important ingredient. But there are limits to what we can know. This is a photo, a reconstructed image of from the Event Horizon Telescope of the black hole at the heart of our galaxy, Sagittarius A star. And there are boundaries. We don't really know what goes on beyond the event horizon. There is a limit to what we can know. And this idea that there are boundaries and that they are a necessary part of the universe is also something that Douglas Adams in The Hitchhiker's Guide to the Galaxy talked about when he dealt with his philosophers who demanded rigidly defined areas of doubt and uncertainty. Now, the first point that we can see is, yes, there are well-defined areas that we cannot know. When we deal with distributed systems, we have the Leslie Lamport's wonderful definition of a distributed system as one in which the failure of a computer you didn't even know existed can render your own computer unusable. And we see examples of this loss of location and service transparency. So my publisher, O'Reilly, this is a tweet from a couple of years back, but it could be any year because there's always fires in California in the summer. And so we have this idea that we have a limit to what we can know. Now, there's actually a more fundamental idea here. Brewer's theorem, better known as the CAP theorem, named for Eric Brewer. It was originally introduced as a principle in 1999. Then he kind of made it a conjecture, and then somebody actually proved it in 2002. So it is actually a theorem. So CAP theorem, if you've not encountered it, CAP, consistency, availability, partition tolerance. Consistency basically means that in a distributed system, if I am trying to obtain a value and I query it and somebody else queries that very same value, that we both get the same value. Okay, we receive the most recent version. Okay, or we receive an error. Availability means you never receive an error, but you are not necessarily guaranteed to agree on the value that you got. You will not necessarily receive the latest update to that value. And partition tolerance basically says, you know what, the system keeps on running even when the network is partitioned, even when there is a breakage. You know, a router has a problem, a server goes down, and so on. Now, the whole point, what is the CAP theorem? The CAP theorem says you see these three things, you can have any two. You cannot have all three. Okay? You can have consistency and partition tolerance. In other words, I can still, if something goes down in the network, what this means is that I can still function. I can still have my client running or something else can run, and I will receive well-defined errors, but the application won't crash. But I will not receive an incorrect value. Or we can have availability and partition tolerance, which means the application still runs, but the values may be stale. I won't get any error modes, but I might be dealing with an outdated version, you know, a cached version rather than the latest value. And we can have this, which is a limiting case, where you actually are guaranteed that while everything is working, you will always receive the latest value and no errors. But the minute there's any crash, everything crashes, or rather, if there's any fault in the network, your application's not going to work. Just as an aside, this is why NFTs don't work. There's all kinds of other reasons why NFTs don't work, but NFTs as a value proposition only work if C, A, and P are all true, but they can't be, and this is demonstrated as a theorem. So this is an interesting thing because this is effectively Heisenberg's uncertainty principle for the network. But it goes further than that. We see it in other formalisms. It's not just physics. We see that there is a limit. So Kurt Gödel, Austrian logician, 1931, found that there were a deep and fundamental flaw in the work of Bertrand Russell and Alfred North Whitehead, their 1911 work, Principia Mathematica, which set out to show that mathematics was both complete and consistent. And it turns out that it cannot be complete. He discovered the incompleteness theorems. So Gödel incompleteness. There are statements that are true within a system, a formal system, that cannot be shown to be true. And that's quite fundamental. And that actually does pop up every now and then in code, though we don't recognize it as such. So we must recognize, first of all, there are boundaries to our knowledge. Now, let's go to this kind of idea of let's organize this. So I'm going to take a kind of 5-order framework from Philip Armour. He came up with this in 2000. It was published in Communications of the ACM. And being a good programmer, he counted it from 0, 0, 1, 2, 3, 4. And 0 is basically, level 0 is the lack of ignorance. Level 1 is the lack of knowledge. Level 2 is lack of awareness. 3 is lack of process. 4 is meta-ignorance. What does meta-ignorance? I will explain what the first 4 mean, but the last one, meta-ignorance, basically means you don't know what the 5 orders of ignorance are. Well, I'm about to tell you that, so it's no longer important. So let's take that one out of play. But also, let me choose a more structured approach to thinking about this stuff. Let me also, I've just realized something else is playing in the background that shouldn't be. I'm going to take a more familiar way of classifying these. It will make the concept a little clearer. The known knowns, the known unknowns, the unknown unknowns, and the unknowable unknowns. So level or order 0, you know what you know. Okay, known unknowns, you know what you don't know. Unknown unknowns is you don't know what you don't know. Unknowable unknowns is you have no way of finding out what you don't know. Okay, these are, and sometimes I get people sort of saying, oh, because they're looking at it from a word point of view. Words are not mathematics, let's be very clear. Sometimes people say, well, what about the unknown knowns? There's no such thing. Or rather, unknown knowns, the idea is that sometimes people say, oh, with the unknown knowns, you know, when you know something, but it turns out you're wrong. That's called the unknown unknown. You didn't know you were wrong. You believed something, but actually, truly, you didn't know it. So that category doesn't exist. I mention that now because every now and then I get an email from somebody who tries to prove me wrong, and unfortunately they're always wrong. This is a known no. I will tell you that in advance. So let's focus on the known knowns. So that's our comfort zone. Okay, our comfort zone is we know what we know. This is how we do. We normally bias our estimates towards that. And so I know that I know nothing. We're not interested in this category, particularly because people have a strong bias towards what they know. What I do find it interesting is that this is normally attributed to Socrates. We don't actually know that he said this. Let's start looking at the known unknowns, because this is where, although we might acknowledge, so for example, a good example of the known knowns, I know that I can speak English. Known unknowns, things you know that you don't know. I know that I can't hold a conversation in German. You know, I mean, I've got Speisekarten Deutsch, and that's about the limit of my German. You know, I can read signs and I can navigate my way around stations and airports, and I can pick up a few clues. But can I hold a meaningful conversation in German? Absolutely not. I know that I do not have enough knowledge of German to be able to do that. So it is not a surprise to me. Okay, so it's a known unknown in that sense. I know that I cannot speak Japanese. I know that I cannot speak Russian. I know these are not a surprise to me. But what is interesting is that we tend to rank such knowledge, we tend to rank it lower, because it's a little bit like thinking like, well, the things I can see immediately around me, and then there are things towards the horizon. I don't see them as well. They're a little more distant. They tend to be smaller. And so we're biased against those. So even though, let's say you're working on some software and there are things you know you don't know. We're going to use a new framework. I don't know how to do it. If you're a Node person and you're suddenly going to start moving to, if you're Angular and you're moving to React, perhaps you don't know React, but you will be biased. You will rank that knowledge down. You will underestimate typically the effort that is involved in that. Okay, so even though you don't know something, doesn't seem to be as important. And this is this leads to the planning fallacy. So this cognitive bias, and these days we are very, very aware of cognitive biases. They come to us from behavioral economics and psychology. Honestly, if you looked at psychology before about the mid-1990s, 2000s, there was not a lot on this, but it was very much formalized through the work of many people, including Daniel Kahneman and his partner, his research partner, Amos Tversky. And if you may have come across Kahneman's book, Thinking Fast and Slow, where he explores these at greater length. They define this phenomenon as a tendency to underestimate the amount of time needed to complete a future task due to the reliance on overly optimistic performance scenarios. This is one of the issues with planning. Even when we know we don't know something, we do not accord it sufficient respect. We kind of overestimate based on other things that we have done. There's also an optimism bias just to go with this. So if I take you back to 1968, the kind of classic and groundbreaking software engineering conference held in Garmisch. What is interesting, and a lot of people tend to think, oh, software engineering, that's all about planning and all the rest of it. And it's very plan driven. That's not the case. It's worth actually reading the original proceedings. I love this quote from Douglas Ross. The most deadly thing in software is the concept, which almost universally seems to be followed, that you are going to specify what you are going to do and then do it. And this is where most of our troubles come from. When you read this, you realize that in 1968, they were fully aware that plan-driven development was not a great idea, that it had many shortcomings, and that they had not seen this work out successfully, even though software development was at a very young stage. And we still know this, but it took a lot of people a lot of time to really appreciate this, and it's still ongoing. The observation, one of the most important observations, again, is to be found. The design process is an iterative one. It is to be found in this document from the late 60s. I think this is really interesting. It's one of those interesting things. When we talk about knowledge, we need to take advantage of the knowledge that already exists. We're very poor at that. I still find people who do not understand this statement. And it is 2023. We have moved on 55 years, and yet we still struggle with this observation. So what does that mean in practice? How do we explore and arrive at more certainty, to pick up on last year's talk, and deal with these gaps in our knowledge? When we recognize there is a gap, how do we fill it? But also looking ahead, How do we also uncover the things that we don't know? So I'm going to pick on a fairly classic cycle, one that is used throughout a business process re-engineering, and it's a fairly standard one, dates back to the 50s. Let me think. Walter Shewhart and then later Edwards Deming helped promote this. Plan, Do, Study, Act, PDSA. For me, this cycle is an almost fundamental idea. Although we might not always follow it perfectly, it's an idealization. It's a very helpful narrative, a very helpful story to go through. That in our failure modes, what we often do is and this is a very common human thing, when we feel like we are losing control of something, what we do is we try and exert control. Yeah? When you lose control, you try and put more control in. Schedule is one area. The details of a design is another. We end up with micromanagement and micro design. Okay, where an architect is trying to specify a lot of stuff that actually probably doesn't matter and is probably missing the bigger picture, but also failing to capture the details that do matter and keep an eye on those. We end up with not a cycle, but a straight through from left to right. We do a lot of plan, and then we do a lot of do. The idea is we need to iterate, plan, do. Now that starts us down the road, but we need a better cycle, a more fulfilled cycle. Study, look at what you've done. Okay, see what's there. And then act on what you have found. That last bit's really important because if you like, people always talk about feedback-driven development. Here we generate the feedback. Here we look at the feedback. Here we act on the feedback. Yeah, to do feedback, you need three things. One is a process that generates. Two is an activity where you take time to try and understand the feedback. If you don't bother understanding the feedback, all you're doing is generating feedback. And unless you're Jimi Hendrix, it's not going to work out well. And then step three, it's great understanding stuff, but if you don't do anything about it, you're not going to get very far. Act feeds into the next cycle. But also it's where we raise new questions. What else don't we know? What are the things we're not sure about? Well, let's find out. Let's do this. Do we know that this resolution, we have problems of a technical nature. Do we know that our plan, write more tests, do more performance analysis? Is that going to resolve our problems? I don't know. It sounds like a good idea. It's part of the next hypothesis. Let's cycle round. Now, sometimes you come across this as plan, do, check, act, PDCA. I'm not really a big fan of the word check. Check sounds quick. It sounds, doesn't sound like study. Study sounds nice and slow. It sounds deliberate. It sounds like you're putting effort into it. Check sounds quick and like you're not really putting a lot of effort into it. And then adjust. Adjust is an alternative wording that Edwards Deming favored later in his life. And I quite like it because I think it's act is, what's the difference between act and do? In English, they pretty much mean the same thing, but adjust is a very specific thing. It's a response or react. It's a response to what you have learned. So the key idea at the heart of all of this, I'm going to quote one of my favorite authors, Neil Gaiman, you have to finish things. That's what you learn from. You learn by finishing things. So the whole point here is that when you recognize there is something you do not know, then do it. Get feedback. Learn sooner rather than later what is actually involved. But then how do we'll actually see the same cycle helps us with the next category, unknown unknowns. The things you didn't know. We need to engage in deliberate discovery. If you have a great idea for your architecture, or you have a belief about your architecture, how do you turn that belief into knowledge? That cycle helps us. But more importantly, there are things you don't know. These are your assumptions. The most common class of the things that we didn't know is the presence of bugs. Okay, it's a particularly helpful message from Lufthansa a couple of years back. Nan, tried to parse Nan, but it is not a number. How very self-referential. But we also see Nans creeping in other places. One of my favorite examples from 2020, when everything was going wrong, is a driverless race car also went massively wrong. So driverless race car, powered by software, drove straight into a wall. During the initialization lap, something happened which apparently caused the steering control signal to go to Nan, and subsequently the steering locked to the maximum value to the right. So this is interesting because basically there was a state problem and it was not caught. Somebody did not write an if statement to check this. Somebody did not check the model. There was an assumption. And that is what is interesting. An assumption is, epistemologically speaking, it's a very interesting piece of knowledge, because you don't normally know you have an assumption until you discover it's wrong. Okay, as I describe here, it's a little bit like stepping on Lego bricks in the dark. Okay, even if you know that there are Lego bricks and you are barefoot, even if you know there are Lego bricks in the dark room, you don't know where they are until you step on them. So I can tell you that I have assumptions. I just don't know what they are until normally somebody shows me something that contradicts it. Oh, okay, I had assumed that. When you say that, when you say, oh, I had assumed that, you have just discovered that you had a piece of knowledge and it was wrong. It was an unknown unknown. And that's a point there. You don't discover it until it's contradicted. How do you find out more? I've used the term from Dan Terhorst North, deliberate discovery. You put yourself in a situation where you are more likely to step on Lego bricks, but to do so without the pain. The idea is the iteration and exploratory nature and hypothesis-driven approach. This is how we want to approach architecture. We don't approach architecture as a master plan or as a document. I'm not going to say that doesn't exist. In fact, that's one of the biggest problems, is a lot of people think that's what architecture is. For me, architecture is about proving hypotheses, formulating and demonstrating that they work. Okay. Oh, I think this would be a good idea. That's great. You can think lots of things. Show me. Okay. That's what it is. When we talk about assumptions, we actually see that this is also the fabric and structure of any system. David Parnas, back in 1971, described this. He said the connections between modules are the assumptions which the modules make about each other. Now, this is interesting because he's talking about dependencies. But the thing is, these days, when we think about dependencies, a lot of people think dependencies in terms of runtime. The term dependency is a little bit older than that. It's not just about runtime dependencies. It's about build time dependencies, your code to code dependencies, not just the runtime dependencies, the libraries you're pulling in, the services you're using. It is also about the build dependencies, which can sometimes absolutely overwhelm a system. So there are dependencies, but normally when we think of dependencies, we think of the thing where you can kind of go through the source code and go, oh yeah, I see that this is calling this, or this class inherits from this. Or when you're looking at the build script, you see, this depends on this for the build. So if this changes, then this should also change, okay? And that can affect your deployment, and your compilation and whatever. But there's also other connections that represent dependencies that are not obviously visible in code. So for example, if you have two things that depend on the same format, so in other words, if I say, oh, I'm reading a field from the database, my assumption is that it's in XML. You're writing to it, your assumption is that it's in JSON. Nowhere, if I change that in your code, there's no build process that is going to catch the fact that we now have mismatched assumptions. Okay, no build process other than testing. But the point there is that's a runtime discovery. Okay, the idea is that that's not if you build up a dependency graph, the fact that you believe in one format and I believe in another is not going to show up. But it's still a dependency, it's still a connection, it's an assumption. Now that assumption may be explicitly stated somewhere, but in many cases they're not. When we talk about using components, we talk about their thread safety. In most of the languages that we use, there's no concept of explicitly defining a concept of thread safety. So you use something based on an assumption. I've had this so many times where people say, oh yeah, I called that class, then we got some errors. I had assumed it was thread safe. And if you look at it, it's like there's nothing that really distinguishes a thread safe class from a non-thread safe one. Thread safety is context dependent. It is not a thing that we look at as a dependency, and yet it is. Yeah, it's a dependency about how we organize time. Now, this idea of structure is important because that's the other way we tend to approach architecture. We talk about it structurally. So I'm going to refer to this book from the 2000s, Architecting Enterprise Solutions, Patterns for High Capability Internet-Based Systems. Now, this book's by Paul Dyson and Andy Longshaw. I'm not really recommending this book, not because it's bad, but simply because of its age. The whole point here is that what we understand as internet-based systems has changed an awful lot in the 15 or so years since this book was published. The world has moved on. And, this book doesn't talk about, this predates microservices, it predates DevOps, it predates a whole lot of stuff. So although there are a number of guiding principles here that still work, and although there are a number of patterns that still work, a lot of it is not current. But there's some really good stuff when they start talking about architecture. And when they talk about architectural definition, they say our position is that an architectural definition is something that answers 3 questions. I really like that idea, that we're going to try and understand something by thinking in terms of the questions, not as here is what architecture is, or here is what our architecture is. What we're going to do is we're going to say, here's 3 questions. Whatever your answer is, that's your architecture, which I think is a lovely way of looking at it. It also plays into this idea, just as with the PDSA cycle. I look at that as a cycle of a process of inquiry. Okay, I think people are obsessed with answers. I'm much more interested in questions. So questions are going to help you. Questions drive you forward. Answers let you stand where you are on solid ground. Questions will make you move. What are the structural elements of the system? What are the things? Okay, if I'm drawing a diagram, what are the boxes or the bubbles? Okay, what are the things? What kind of things are there? Well, there are processes, there are classes, there are functions. Okay, there are services, there are threads. These are all things. They have that sound about them. They are things that you would draw and could point to. Now let's talk about the connections. Okay, we've got the kind of components, the elements. How are they related to each other? This inherits from this. This calls this. This uses this. Okay, well, this calls this synchronously. This calls this asynchronously. Okay, I'm making statements about how they relate to one another, both spatially and in time. But that's not all. What's the rationale? Okay, what are the underlying principles and rationale that guide the answers to the previous 2 questions? Now, what I find interesting here is this breaks down to 3 question words. What are the things? How are they connected? Why? Why is it like this? And that is the hardest question to answer. When you arrive at a new code base, the first one is actually quite obvious. These are also in order of visibility. Think about it. Open up a source file. What's the most visible thing? The things. The things are the most visible. Yeah, okay. If you're working, if you're working in the Java or C#, you open it up, boom, there it is, class, interface. These are the things. Okay. You open up a build script. Oh, okay, you can see the components and how they're, you can see those there. You look at the version control system. Okay, you see the files, the things. You see the folders, the things. Okay, if I've got a dashboard of the running system, it's things. It's the running processes, the running services. It's the things. It's number 1. Number 2, how are they related to each other? That information is there, but you have to do a little more detective work. If a class implements an interface, that's visible, but you have to look closely. And if you want to see the whole tree, you'll look really closely. You can see a method calling another method. You can find out which processes are using each other. The information is all there, but it's not as obvious. It's not as clear. The third category, why is it like this? That's not always obvious. So how do we capture this? How do we organize our knowledge about this? Because that knowledge exists in people's heads. Sometimes it's implicit in the code. Sometimes we have to do a lot of detective work to find it. So Michael Nygaard came up with an approach in 2011, ADRs, Architecture Decision Records. And he made this observation in motivating these. One of the hardest things to track during the life of a project is the motivation behind certain decisions. A new person coming onto a project may be perplexed, baffled, delighted, or infuriated by some past decisions. Now, this is the problem. The challenge we now have is that without understanding the rationale, the consequences, this person has only 2 choices. You blindly accept what is there. You're looking at it going like, well, I guess that it's probably a bad idea to change this. I guess somebody knew what they were doing, or I simply fear the consequences of changing it. Or we change it. You look at it and you go, this doesn't seem relevant anymore. Like, this is a stupid decision in my experience. Let's change it. Now, the problem is that neither of these is a good option. Don't blindly accept something, because one of the things that makes a legacy system is not that the code is bad. It's that the code is dependent on decisions that are no longer relevant. That the reason that something is the way it is no longer absolutely relevant at all. You know, I worked on a 64-bit, or I reviewed a 64-bit system. And so this is a native code, it was C++. It's supposed to care about performance. And I'm looking at a 64-bit system. There were lots of strange decisions that made the code more complex that dated back to the 16-bit era. None of these was helpful. Every single one of them made the development slower and they made the performance slower. Okay, because people were afraid to change it. They feared it. They didn't understand why it had been that way. So how do we resolve this? Now, sometimes people say, oh, documentation. Yeah, that's half the answer. The question is how? How do we make our documentation keep pace with our thinking? And this is the idea that Michael Nygaard came up with. And it's very similar to ideas that I'd seen before and were quite helpful. He said, we will keep a collection of records. Now, the first thing is the term record immediately implies that it is short. It is not heavily detailed. It's not a big document. For architecturally significant decisions, those that affect the structure, non-functional characteristics, dependencies, interfaces, or construction techniques. Okay. Now, what he's proposing is rather than we're going to come up with a document, we're just going to come up with little things. Okay. These are supposed to be easy to maintain, easy to write, easy to check on, and they're going to be version controlled. And more importantly, they're going to be in the same place. The same place as what? The same place as the code. I despair when I see people trying to do ADRs and say, oh yeah, all our code's over here. We put all our ADRs in SharePoint. Do not do this. This is a bad idea. I mean, I know that people think they're doing a good thing because the company standard might be SharePoint or something like that. This is not a good idea because the whole point of ADRs is you are documenting stuff with the code. Unless you're also trying to keep your code in SharePoint, and at that point I'm going to step back and run away. Unless you're also keeping your code in SharePoint, then it's not, you've just recreated the very problem you started with. One of the biggest problems that we have is that documents are kept separate from the code that they document. And documents just get bigger and bigger. They don't follow the same version control things. People have to fire up a different tool. If I can edit it in my IDE as easily, or no, in fact, even better, I shouldn't need an IDE to use it. I should not need a special tool. I should just be able to use an editor. So I'm saying all of this, even though I haven't fully explained ADRs, because I know people getting really excited about ADRs the last few years, but I just see people making such a mess of them. Okay, yeah, they ignore all of the motivation, and very few people have ever read Michael's original article that are actually applying it. His article covers pretty much everything you need to know. That doesn't mean there are not better explanation articles out there, but people ignore the fact that he got most of it right the first time. Well, I say the first time. His company had been working with these and had experience in it. So the point there is, if you're going to do ADRs, they're in the same place as your code. They are version controlled with your code. They use the same kind of tooling as your code. They do not do anything that is different. An ADR should be editable in a text editor. If it requires any more, then you are not going to be successful in the long term. I am prepared to be wrong on that, but I don't believe I will be. So here he says, an architecture decision is a short text file in a format similar to an Alexandrian pattern, which I'll come back to in a minute. What does he mean by that? And this is what I find interesting, is I've spent a lot of time. I first got into patterns 30 years ago. Yeah, it's 2023, so that's right, which makes me feel depressingly old at this point. And the same time he was doing this, I did an exercise, a workshop at a company where we explored some of their architecture and expressed it through patterns, but I would now call them ADRs because these are not patterns that were generally recognized by others. They were just basically documenting their key decisions. So we used a similar format, very successful, very effective. Each record describes a set of forces and a single decision in response to those forces. Note that the decision is the central piece here, so specific forces may appear in multiple ADRs. What we mean by force is something that kind of causes you to think, yeah, this is a driving force in this design, or this is a conflicting force. I need this to be faster, but I also need it to use less space. There you go, I've set up two forces, two drivers that are in contradiction or contention with one another. So I'm going to give you a very simple example here. People like the library example. This is a timeless example in the world of software. What I love about this example is that when was it? About 20 years ago, 20 or so years ago. I was preparing a version of this for a workshop, and a work colleague was looking and says, "Oh, Kevlin, you're still using the library example." And he's kind of like, "Yeah, you know, this is a really old thing." I'm gonna guess if you looked around, you'd find the library example dates back to the 1960s. It certainly was common in the 1970s, but and he said, "Oh, you know, Kevlin, I'm more, you know, I try to use something more up to date." He says, he told me, he said, "Yeah, I'm using video stores." Which I think is brilliant. Video rental stores. I had to explain to my 17-year-old what a video rental store was recently. He had no idea. Okay. My 20-year-old was just about aware, but had no recollection of them. But the 17-year-old was amazed that this was ever a thing. He was disgusted by the fact that you're using physical videos that other people have used. And he said, "Yeah, but Dad, you know, how does this work? When you go to the video store and they don't have the video that you want to rent, what do you do?" I said, "Well, it's like this, son. You get another one. You get something else." It's like, what? He's a kid of the streaming era. He cannot understand that you know, anyway, that's some relevant comment on availability, which we were talking about earlier. Okay, so the library example. Let's keep it simple. We've got a library system. That's the software system of interest. We've got two actors, two user roles, a member and a librarian. So a member can borrow up to 10 books at a time. Okay, we've got some various requirement constraints here, which we can formalize as user stories later. A member cannot borrow any more books if they have any overdue loans. A book loan lasts for 4 weeks before becoming overdue. When an overdue book is returned, the member is fined an amount based on the number of days overdue, so maybe 20 cents a day, for example. Members can pay off all or part of their balance of fines. A loan can be renewed up to 3 times by a member. Excellent. So we've got a set of requirements. Okay, this is our initial, let's just say our system now does this. We've developed it, it does this. In terms of other roles, librarians are responsible for registering new members and also registering new books. And then to keep things simple, because I'm going to make this very simple, we're going to just say that don't worry about the database. Persistence is magical. It's based on in-memory object-oriented database. In other words, your in-memory object-oriented model is fine. That's it. That's all you need to worry about. Don't worry about the database. Also, security is OS based. You don't have to worry about security for the app. Nice and simple. Okay. So we've eliminated a lot of the complexity. Now, here's the backlog. Here's the future. Well, we don't know it's the future. It's a possible future. We're going to support child membership. Maybe children pay less for overdue books. Maybe they pay nothing. We're going to add a reference section to the library. What's that? It's often central libraries or university libraries have reference sections. So where you are able to go in and look at a book, but you cannot take it out of the library. You cannot borrow it. We're going to support additional services like email and things like that for members. We're also going to add other media such as DVDs and Blu-rays. And we're going to allow members to reserve books that are not currently in the library so that when somebody brings them back, they are first notified. Okay, so that's our feature backlog. That's the work to do. This is the work that has been done. This is the work to do. Now, we can come up with a really simple kind of entity style object model for this. Library system, member, loan. We can see the kind of relationships. The library system has many members, many loans, many books. A loan is a relationship object between a member and a book. There's actually a lot to say about that. I'm not going to say that today. A member can have many loans. A loan is always against one member. Okay, when a loan is always against one book, but a book may be optionally on loan. Now, if we just threw this into code straight away, we'd end up with an awful lot of code in the library system. It'd just be a big monolithic thing. So first of all, we're going to factor out responsibilities. The temptation is to sort of say, oh, we've got a manager layer here. Just because you've got a management layer does not mean you have to call everything manager. We can normally find better names in the domain. And these are actually decent aggregate responsibilities, taking a term from domain-driven design. This is the membership. This is about loaning, and this is the catalog. We may also recognize, as we refine our understanding, that when we use the term book, it is ambiguous. There are two concepts in play that matter here. There is a book copy and a book title. Okay. A copy is the thing that you hold in your hand. Okay. This is a book copy. I'm sure we could have lots of titles. Okay. Or rather, we could have lots of other copies of the same title. Okay. So I mentioned 97 things every programmer should know. I still have a couple of copies of that. But notice I'm now being specific because I'm trying to disambiguate. You know, I have a couple of copies of that book. When I say that book, I'm now referring to book title or the product. Okay, so we differentiate between the book idea, the concept, the content, and actually physically this one here. And that gives us a slightly better understanding. Now, of course, there are other classes. I'm not going to draw those on. There's going to be little helper classes, you know, like an ISBN class to identify our book titles. There's probably a membership ID class. There'll be other classes that are used for exceptions and all kinds of stuff. But let's just focus on these. I call these the kind of like the landmark, the big load-bearing structures. So I'm now going to ask you a question. We need to package up the system. I'm not going to put everything in the same package. I need to organize these into packages, components, subsystems, however you want to call it. And there are two typical ways that people can use, okay? Either we can do this basically by organizing around, you know, layering with respect to the responsibilities of these classes. So we group the managers in one layer. So if you like, we have director, managers, and entities, okay? Option A. Option B is we organize it with respect to subdomain. In other words, member and membership go together, loan and loaning go together, book, all the book stuff goes with catalog. We separate it out like that. So we have two choices. Which one of these should we do? Now, what I'm going to suggest to you that we do, because the feature that I normally rely on in Teams and Zoom is not present in WebEx, I'm going to say, just put it in the chat. Which one you think, A or B? What would be your instinct, given what you know? What would be your instinct? How should we organize this, A or B? Just pop it into the chat. 3 suggestions, 4 suggestions, 5 suggestions. Yeah. Pretty much everybody's solid on B that I'm seeing. No, okay. Cool. Well, I have good news. B is the most appropriate packaging. Yay. Okay. So why is it the most appropriate packaging? Well, because it feels right. Yeah, we could do that. Let's do something better. If we take the feature backlog, our anticipated future, doesn't mean it's going to be right. We don't yet know everything. But what we're going to do is we're going to justify this. We're going to say, well, if instead of focusing on the classes, if I focus on the package, and then I introduce, we've got 5 changes listed here. There are more potentially, but let's just focus on these 5. Which packages would I be touching to implement each one of these? It turns out that if I do it with A, then to implement any one of these, I will touch every single layer. The library is effectively the library class is effectively the facade, so we expect that one to change in every case. But notice here, support child membership for the library. I probably touch that. I'm probably going to touch that, and I'm probably going to touch that. But from a practical point of view, a coarse-grained view, I will touch every single thing. If these are components, I will need to redeploy every single one. Okay. The point here is it has consequences for the build. It has consequences for the way we view and manage things and how we perceive change. If you look at B, it's a different story. B, yep, I'm going to change this for every single one. But look at this, really different stability. I'm going to change for child membership. I'm not going to have to modify the catalog, but I will modify this. It localizes the change. But adding other media for borrowing, I'm going to modify this, but it doesn't make any difference to the membership. So it localizes. The idea is that B localizes this, and it's going to give us a structure a bit more like this. Right, so now we've made a decision. We had 2 choices. We have made a decision. It's going to end up like this. Let's do an ADR. So ADRs are normally written using Markdown. Not always. You know, it's not a requirement. It's just that's a common example, particularly if you're using something like Git. So we can go ahead like this. We can say, right, partition packages according to subdomain. Context. This is where we kind of tell a story, the situation that we're in, and we try and make people aware of the forces. We are developing a library system, have an object model that contains classes for members, loans, etc., etc. We can package according to technical role or layer in the system, i.e. have a manager layer above the entity layer, or we can package according to the subdomain, e.g. membership, learning, and catalog. What's the decision that we have chosen? We partition the packages according to the subdomain, because this is the most likely to localize changes already found in the backlog, i.e. changes are localized to membership or to catalog rather than cutting through all layers. What is the status? We accept this decision. Okay, that's the current version. What are the consequences? Local package and therefore deployment stability in the face of most anticipated changes. Some responsibilities can be easily moved from entity to aggregate or vice versa without affecting other packages. That's cool. So in other words, validation, do I do it in the member or the membership? You know what? It doesn't matter. You can move it between the two and it stays local to the member package. So we've got localization, we've got encapsulation at a larger level. As it stands, this design results in cyclic dependencies between packages. Oh, not all consequences are positive. Yes, it does result in that. If we look here, we see that there is a cyclic dependency there and one there. So yeah, that's a bit annoying, okay? But that is a consequence. We're just showing everything that happens. If we change manager or entity policy, that will affect more packages than the alternative design. That's true. If we've got a particular way of doing managers or a particular way of doing entities, then that could be an issue. Now, I'm going to move away from that format, but the idea here is, notice this is the full ADR. In other words, this is almost like an extended commit message. It should not be bigger. Do not do what I saw one company doing, which is producing long Word documents on this. That's not how you do this stuff. They're supposed to be short. They are supposed to be, you can put them on one screen. I referred to this workshop I ran at a company around 2011, where what we actually did is we wrote on very tall whiteboards. I got everybody to write their decisions and their rationale on whiteboards. Because people, if you give them a document, they will fill it up. If you give them a whiteboard, people write more slowly and they write larger. Now, let me show you the other decision. Partition packages according to the technical role of classes. Okay, the decision, we partition packages according to the technical role, i.e. the relative layer in the code, because this groups similar code, concept styles, and dependencies together. Manager objects are separated from entity objects, which are a lower layer. Status rejected. Now, notice what I'm doing here. Most people don't get this. What they end up doing is trying to put all of the discussion of the alternatives in their original ADR. Now, the funny thing is, so if we version control this as rejected. Let's just, so the point there is they put it all in the other one, but that's not the decision. The decision is there were two choices. You can record the decision that you did not take. Do not put it all in one place. Now, the funny thing is, by the time ADRs were invented, I already had a lot of experience in this thing. We spent a whole book teaching people how to write this, because remember I said that, Michael Nygaard talked about the Alexandrian pattern form. These are basically, they use the same writing considerations and principles as patterns. And I've spent years focusing on that. There's a whole set of practices about how to do this well. And a lot of people are unaware about this. So what we've just done there is I'm going to pick on something that I talked about in last year's talk. When from 97 Things Every Software Architect Should Know, when a design decision can reasonably go one of two ways, an architect needs to take a step back. I had this idea of use uncertainty as a driver. Instead of trying to decide between options A and B, the question becomes, how do I design so that the choice between A and B is less significant? The most interesting thing is not actually the choice between A and B, but the fact that there is a choice. In other words, where there is a choice, there's a discussion, but make it visible, capture that knowledge, also capture the fact that you didn't take a decision. That's why that status field is there. It's there for version control. If next year you suddenly realize, you know what, the other approach for the changes we've experienced in the last year would have been better, then that's the whole point of the version control. You change it without having to change all the description. Yeah, we reject the one we accepted and accept the one we rejected. We change our mind. Now, this is not news. We propose that one begins with a list of difficult design decisions or design decisions which are likely to change. Each module is then designed to hide such a decision from the others. This is 1972. So that kind of tells us how we think about these things. And we actually find a relationship there with the whole patterns thing. So let us just close with the unknowable unknowns. The things we do not have a process for discovering. Most unknowable unknowns are to do with the future. Here's the definition I used last time. All architecture is design, but not all design is architecture. Okay, Grady Birch. This is good. I like this. The key thing is this part. Architecture represents the significant design decisions that shape a system, where significant is measured by cost of change. Now, the problem is you don't know what you're going to need to change. That's in the future. You don't always know the cost of it. So in other words, the knowledge that you need to know whether something is truly architectural or not, or significant, lies in the future. How do you know that? So I'll use Ralph Johnson's observation. Architecture is the decisions you wish you could get right early in a project, but you're not necessarily more likely to get right than any other. This is the whole thing with unknowable unknowns. You have no process for finding out except by going into the future. There is nothing that I can do now to find out what our changes will be in future. I can do certain things. I can do a lot of things that will help me make it easier if they arise, but I don't know that they're going to arise. This is beyond assumptions. The observation here is the prediction is very difficult, especially about the future. What I like about this quote is that we don't know who said it. I mean, it was probably Niels Bohr, the physicist, the Danish physicist. I would like it to be him because he's known for quantum mechanics, but we don't actually know that he said that. And what's important is that this quote was a quote from the past, and we don't know who said it. How on earth are we going to be able to predict the future if we can't even figure out who did something in the past? The future is hard. We do not know what is going to happen there until we arrive there. This is one of my common beefs with the idea of the roadmap. People often talk about an architecture or product roadmap. So, back in 2020, I went and Googled a whole load of roadmap PowerPoint templates. There's a lot online. And a lot of them look like this. They show an actual road. It's kind of cute. Put your stuff there. This is Bristol, where I live in the west of England. And it's a roadmap. What you will notice about this roadmap is it has more than one road, which is why we have roadmaps. Because we have more than one road. If you only have one road, you don't need a roadmap. You just need an itinerary. The whole point of a roadmap is that it shows you possibilities and options. When you're driving, the dynamic roadmaps we now have, if you're using something like maps, if you're driving, it's just like, oh, this is going to be 10 minutes slower than this because something happened that we didn't anticipate. You didn't know that in advance. There's no way you could have known that. But now you can respond to it. Okay. So responding to change over following a plan sounds kind of familiar, but there's an important point here. That's the value of roadmaps, is that you're able to say, look, here are 3 possible paths into the future. I can't tell you which one is right, but I can show you there's more than one so that we can adapt as we go. This idea of predicting the future is disastrous. We can actually tell that this particular template was created in 2018 because of the dates that they use. But I'm sure you can tell, nobody knew that 2020 was going to bring about a global pandemic that changed the way that we worked and was going to disrupt our clients as well. The point there is this is an unknowable unknown. The only way to find out that something has a particular consequence is to experience that consequence as it happens. There is no process other than having a time machine that would have allowed you to know that. It also means we need to be cautious when people talk about prioritizing by business value. We're going to prioritize our requirements. You should work on this by. I'm not saying you shouldn't prioritize, but I am very picky about language. You cannot prioritize by business value. Okay. And this is important because this is you cannot prioritize by business value because it's against the laws of physics, not because I have an opinion, but because it's against the laws of physics. You don't know the business value of a feature until the future. And at that point you go, oh yeah, we were right about this. Alternatively, yeah, we got this completely wrong. Customers didn't want this feature. We thought they did. You can prioritize by estimated business value, but you can't prioritize by actual business value. Yeah, actual business value is a thing that happens in the future. You do not know it, and there is no way to know it until you arrive at the future. It is an unknowable unknown. It will only make itself known at that point. So on that note, what I'm going to do is, there's a whole bunch of other stuff that I could be saying, but I'm also keenly aware of the time that it is getting late. So I will close with an observation here that tells us an important point. It's a lovely book. I can't remember if I used it last time, but I do quote often from it. 101 Things I Learned in Architecture School by Matthew Frederick. It's about real building architecture, but many of its insights are applicable to any design-based discipline, such as software. And he talks about all of these uncertainties. And he says, well, how do we as architects adapt to the fact that we don't know everything? That we are always, my words now, incomplete knowledge. We are always working with incomplete knowledge. So therefore, rather than applying more control, we take a step back and we try and categorize what are the things I know, what are the things I think I know. We try and get confidence levels. We formalize what we do and don't know, and then we work to know the things that we don't. But we also work to constantly on the lookout, observing what is it that we have just discovered that might affect us that we didn't anticipate before. Always on the lookout for our assumptions. It's a heightened state of awareness. And also anything that changes that was beyond anticipation. We move through 0, 1, 2, 3, those 4 key ideas, 4 orders of ignorance that are more important to us. And we use that to recognize what is the nature of our knowledge, and we record in as light and accessible a way as possible. Our code records something, our test records other things, our ADRs allow us to capture elements of rationale that might otherwise only live in people's heads or in well described commit messages. Not most people's commit messages, but you can put reasoning in there. Let's make it easier for ourselves to uncover this. So on that note, I am going to stop here and just ask for any questions that you may have. At the moment, I'm getting some pretty solid silence, which might mean that you're digesting your dinner or still eating it, actually, or that everything I said made perfect sense, or that you're so confused by everything I said that you have nowhere to even start with your questions.
I think I'm
But
gonna
I
go
am happy
with
to take
B.
questions.
You made a lot of sense to me. I recognize a lot of the things I see in my work, especially the part
And just
about.
while I'm kind of hanging on there, I will be sending through copies of the slides PDF, so you can kind of come back to that in future should you wish.
And I can tell you why you don't hear anything, because everyone else was muted.
Yeah, that tends to. Okay, so I've got a couple of comments here. It made perfect sense. So
Yeah. One thing that you discussed was kind of an eye opener for me. The part about ADRs.
Yeah.
We're trying it at the moment, or we're doing it at the moment. Pretty big ADRs, in fact.
Yeah.
And that's our main problem. Our ADRs get really big, really fast. And we try to encapsulate all the discovery, all the decisions, all the alternatives into one ADR.
Oh, yeah, that's yeah. Hang on, just give me one moment.
Oh boy, that was so wrong. Now he's gone.
No. Right, this is the book. Okay. No, I'm not trying to sell books. This is Poser 5. This is published in 2007. We have whole sections on how to write patterns, how to organize your forces, but also the issues that patterns can get. Their descriptions sometimes get really big and very, very general. What you end up with is so that decision that I showed you, I've run that in class a couple of times. In fact, I did it for a company in Prague in January, if I've got that one right. But we did ADRs. I'm just trying to remember if I use that example. But what people often end up doing is they call their ADR something like packaging decision. Well, that's not an ADR. That title, the name of the ADR needs to be the decision. Packaging decision is describing about the decision, but it is not the decision. Yeah, it's so. For example, because we're currently having our kitchen done, when I leave this talk, we're going to have a takeaway. It should arrive in the next 5 minutes. We're going to have a takeaway. I had to make a meal decision before I started doing this talk, so that my wife could order in advance. What decision did I make? Oh, I made a meal decision. That's not a decision. I chose noodles. That's a decision. Okay, I could have chosen noodles or I could have chosen rice. There are 2 basic options on the menu, noodles or rice. The decision I took was noodles. The decision my son took was rice. It is not meal decision. That's not the ADR. My ADR is noodles. I chose noodles. It's specific. Now, if I changed my mind, then it's a different ADR. I'm going to have, right, I don't change the ADR. The only thing I change about the original ADR is I go from accepted to rejected or not accepted. And I have to go for the other ADR. Maybe I didn't write up the other ADR because it wasn't interesting to me at the time, but the idea of writing the alternatives, and we talk a lot about alternative patterns in this, because we say, actually, that's the way you kind of capture some of the design space. And that's a very common thing. I see people trying to put too much and you end up with masses of discussion. I'm not saying you shouldn't have any discussion. The example I showed you, I did mention the other thing. I said, there's a couple of ways of doing it, but all the trade-offs, I don't do the trade-offs of the other ones. That just makes it big. That's a separate decision. And in other words, think about it in terms of modularity.
Mm.
Yeah, we make it cohesive. This decision is about this decision. It can reference the other decision, but only to say that's the alternative, that's the other one, or these are the other ones. We don't have the big discussion about all the trade-offs. The trade-offs are about this one. That's the most important thing. Yeah. So obviously when they're small and there's not much to say, we probably don't do that. It's a little bit like a piece of code. But when it gets a bit large, oh, now I need to pull things out. So that, for me, is the more I've done this in recent years, I kind of assume, because obviously I have this bias towards how I think about this because I put so much effort into it years ago, but I'm seeing this problem come up again and again. And it's also implicit in what Michael talks about. If you actually read his original text very carefully, you'll see that's kind of what he's implying. He's not saying you should have, an ADR per decision category. It's per decision, and that you might want to document things elsewhere. That is often missed because he only said it in one sentence, if I recall correctly, 1 or 2 sentences at most. So yeah, that's food for thought.
A lot, actually, a lot of food.
Yeah, yeah. I don't think it's as good. I don't think it's as good as noodles, but it's food for thought.
It's good for spaghetti code.
Yeah, there you go. That is okay. You win. Okay.
No. I'm just applying this in my head, and I'm discovering that almost all our ADRs are in fact, I think, 5 or 6 separate ADRs. So
yeah.
It's really
it makes it easier to see when they're laid out. It's like, oh, you could have done this, or you could have done this.
Yeah.
The problem is we tend to group things together too much. Yeah. So so at least I've caused one person to think very heavily. So I don't think that's a good thing, or if it's a bad thing, but it's a thing.
It's a thing. Yeah. Thank you.
Yeah.
Oh, so anyone else got questions?
Oh, good question from Alexander. How do you avoid duplication in the context? Kind of you don't, and that's kind of okay. I know that we try, so we're constantly caught between this tension of don't repeat yourself, okay? DRY principle, the reduction of duplication of knowledge. But at the same time, we also need to have things be standalone. Here is this decision. The problem is that sometimes we do try and treat other forms of information a little bit too much like a code. In other words, I should remove all duplications. Like now I can't read it because everything's in 2 different places. So I just generally tell people, you know what? Copy and paste it because your context is supposed to be fairly short. Okay, now I've got to be very careful here. Bits of the context will be duplicated, not all of it. If you look back at the 2 examples that I showed, you will see that there is a slight difference in the way that I have framed the context, but only very slight. That will be available in the slides. But I don't think there's anything problematic, but particularly as it should be short. That's the thing. I don't think it's a big problem to have a little bit of duplication there, because we also duplication is useful for allowing things to be isolated. Yeah, in fact, this is an interesting thing. We have 2 pieces in 97 Things Every Programmer Should Know. One is don't repeat yourself, and another one is beware of sharing things and eliminating duplication. Both of these are kind of a balance, and we're constantly in that balance. So when it comes to a piece of information that I am communicating with you, then a little bit of duplication helps localize it. I can read the ADR on its own and understand what it is that we have done. without having to look somewhere else. But if I am interested in the alternative trade-offs, then I go somewhere else and I can see the trade-offs there more visibly. So the variations there become more visible. So yeah, we do pay a slight duplication cost for it, but we get a decoupling or simplicity. It simplifies the thing.
That's
Yeah,
kind
it's a balance, but I think that's a very important one that you highlighted, Alexander. But yeah, there is a balance there. The answer is not always obvious, but it is always worth trying to explore it.
That's also one thing I discovered in the last few years. We try to avoid duplication at any cost, usually, and this is not good in many cases. So
No.
we try to abstract. We try to combine things that should not be combined.
Yeah, it is a difficult. Hang on. So hang on. Let me just say. So it is a constant. Yeah. So that's the problem, is that we do end up with just like, we should not duplicate. And actually, we find that that's a great piece of, it's what I would call a recommendation, not a rule. And there's a very subtle difference. And the way I always talk about recommendations is they're 90 to 95% of the time, whereas a rule is like 95 to 99% of the time. It's the default. All other things considered equal, you know what? Don't duplicate. Eliminate duplication. But there is a strong and ever-present group of things that duplication will solve. And that's a really important idea. And funnily enough, I was just telling somebody yesterday about exactly this, visiting a company where the problem they had is they tried to eliminate duplicate code. They were trying to do reuse. Actually, it was slowing them down, but not in a good way. I don't mean slowing them down because they're trying to really be careful about it. No, it was the fact that they were trying to reuse across two different teams, and they were trying to do that, but the one team was slowing the other down, and this team was slowing these guys down. In other words, they were working against each other rather than with each other. And it turns out the reason was simple. They were on different business cycles. We had one team that had been going for 10 years, and they had a kind of big consolidated code base, a bit legacy in places, but still, this is the money machine for the company. Then they have a new product, which is going to use slightly different technologies and is supposed to be experimental. In other words, it has a very different rhythm. It's not yet settled. It's not calm. And so therefore it's mismatched. It's like mismatched gears. If you ever put your car into first gear, or your car's in fifth gear and you're stationary, you will find this does not work out well. Okay, the gears are mismatched. It's not to say, so my advice to them was, forget trying to eliminate duplication, or to be precise, stop trying to eliminate duplication for now. When the other thing has settled, because currently it's kind of like, if we did this kind of like, this one is like, it has a rhythm like this one has a rhythm like this, and it's all over the place. When this one's settled, then you might consider they are now both in sync. Now their business cycles and their development cycles and their cultures are more compatible. Now trying to eliminate duplication. And I always think of it as a long-term goal, not a short-term. But if you just try and take it as an absolute rule, it will work against you in such cases. Okay, I'm going to take the last question from Sebastian. Do I have a recommendation how to approach ADRs in a legacy system which didn't have ADRs right from the start? This is a great question. An ADR, right, so let's go back to ADRs, short and sweet. And sometimes actually you might just put a placeholder, just the name, a descriptive name, that's it. So let's just say we have got some code and we are introducing somebody to it. We're onboarding somebody, we're introducing, and we're talking about this, and they go, oh, well, why is this like this? And you go, oh, it's like this. And wait a minute, let me just open up a text editor. Let me just capture remember what I just told you? Let's put that in words, okay? Right, check it in. In other words, you do it retrospectively. Don't worry, sometimes it just has to be a placeholder. That's enough. Perfect is the enemy of good, as often people say, because writing an ADR is a big thing. Actually, the best ADRs, the best process for writing ADRs is by having a conversation with somebody, because there's so little text. It's not a typing exercise. You can sit there and go, well, hang on, what about this? You're literally just trying to talk through something and capture that. And you can do it retrospectively. You can do it in a meeting. You can do it while introducing something to somebody. You can do it during a code review. So in other words, do it. So for legacy systems, do it opportunistically. You will never get perfect coverage of all of your decisions, but some of them may be more obvious. If you keep talking about them, you say, wait a minute, let's just do this. Even if it just is a 5 to 10 minute activity, just to put down some rough notes, you have moved it on. And that's the whole point of a version control system. You get to put a later version in. When you come back to it and say, oh no, there's a little more detail we need here. Treat it as progressive. Treat it as like sampling the space. You're never going to get perfect coverage, but you can always take advantage of an opportunity. And the point is, we always have these conversations during reviews, during other meetings, even just on our own, just thinking through something. And there's a lot of knowledge that happens. All you just got to do is connect your fingers to that and put it in an editor. Just even if it's 5 or 10 minutes, it doesn't have to be perfect. So therefore, take advantage of that. Yeah. So, you know, accept that it's not going to be perfect, but do it retrospectively. That can be very powerful. Okay, folks, on that note, I am going to say we are done. You have my contact details and you will have the slides after I've eaten.
Thank you. Thank you
Okay.
again, Kevlin.
Have
Always.
a good evening.
You too. Thank you.
Yeah.
Always a pleasure having you here. And,
Likewise.
to the other guys, thank you for attending. This video will now be stopped.